Welcome to Things You Don't Know. This is the sixth in our series on body secretions. Yeah. Today, we're diving into the marvels of saliva, for sure. Saliva is more than spit. This episode will cover the role of saliva in oral health and digestion, how it can indicate health issues, how saliva is produced, and the science behind saliva testing for medical conditions. So, kind of a broad sweep. We do want to welcome Dr. Edgar Lewis, a friend that I met when I was teaching at American University. He is a retired biology professor. So, we welcome to the podcast Dr. Lewis.
Yes, welcome, Dr. Lewis. Thank you very much for joining us for this episode.
Thank you. It is a pleasure to join you gentlemen in bringing the often overlooked topic of saliva, which plays many important roles in the body.
Let's start with where saliva is produced. Saliva is produced by three pairs of major salivary glands, as well as numerous minor salivary glands scattered throughout the mouth. The parotid glands, which are located in front of and just below each ear, these glands produce a very watery, enzyme-rich saliva. The submandibular glands, which are found beneath the lower jaw, these glands produce a mixture of watery, mucous saliva.
And let's not forget the sublingual glands located under the tongue. These glands produce a thick, mucus-laden saliva. Saliva production is a complex process involving the salivary glands and a well-coordinated neural and hormonal regulation system. Maybe we should take a detailed look at how saliva is produced.
Saliva production is stimulated by both the presence of food and the anticipation of eating. Sensory signals, such as taste, smell, sight, and even thought of food, trigger this response. Mechanical actions like chewing and swallowing also stimulate saliva production.
Neural regulation also plays a role in the production of saliva. The process begins with sensory receptors in the mouth, sending signals to the salivary nuclei in the brainstem, specifically in the medulla oblongata. Parasympathetic nervous system activation via the facial and glossopharyngeal nerves stimulates the salivary glands to produce and secrete saliva. This is the primary driver of saliva production. The sympathetic nervous system can also influence saliva production, but it typically produces a smaller volume of thicker saliva.
Hormones play a role in regulating saliva production. For example, aldosterone helps regulate the sodium and potassium content of saliva, adjusting its electrolyte composition. See, Dr. Lewis, I really did learn some things. Acivar cells, the acivar cells in the salivary glands produce the initial saliva. This primary saliva is isotonic and contains water, electrolytes, mucus, and enzymes like amylase. As the saliva passes through the ductal system of the glands, its composition is modified. Sodium and chloride ions are reabsorbed, while potassium and bicarbonate ions are secreted, making the final saliva more hypotonic relative to blood plasma. The final saliva is secreted into the mouth through ducts. The ducts, as I say, they secrete it into the mouth. The composition and amount of saliva can vary depending on the type and the intensity of the stimulation.
In summary, saliva production is a highly regulated process involving the coordinated actions of neural and hormonal signals, with the salivary glands playing a central role. This complex process ensures that saliva is produced in the right amount and composition to maintain oral health, aid in digestion, and perform other critical functions. Saliva, often taken for granted, is a powerhouse of functions in our body. Saliva is at work every time we chew, speak, or relax. Let's explore these ideas and see how saliva contributes to health and digestion.
Saliva plays a crucial role in maintaining oral health. It helps keep the mouth moist, make it easier to chew and swallow food. Moreover, saliva contains enzymes and proteins that help to break down food particles, neutralize harmful acids produced by bacteria, and wash away food debris and dead cells. This cleansing action helps to prevent tooth decay and gum disease. Additionally, saliva contains calcium, phosphate, and fluoride, which help strengthen tooth enamel and even repair early signs of tooth decay.
Saliva kickstarts the digestive process even before food reaches the stomach. It contains the enzyme amylase, which begins the breakdown of carbohydrates in the mouth. This early stage of digestion is crucial to the efficient processing of food. Saliva also helps to form the food into what they call a bolus, which is a small rounded mass which can be easily swallowed and transported down the esophagus to the stomach.
Saliva is more than just a digestive aid, it is a mirror reflecting our overall health. Various health conditions can influence the composition and flow of saliva, making it a valuable diagnostic tool.
To kind of summarize some of the functions of saliva. Saliva lubricates the mouth, making it easier to chew, swallow, and speak. It also performs a protective barrier on the teeth and mucosa. Enzymes in saliva, like amylase, start the breakdown of carbohydrates. Lingual lipase begins the digestion of lipids. Antimicrobial action comes from the fact that saliva contains antimicrobial agents like lysozyme, lactoferrin, immunoglobulins, which help control the microbial population in the mouth. Saliva also helps neutralize acids in the mouth, protecting your teeth from decay. And, hey, it also helps with taste because saliva is very essential in dissolving food particles, allowing taste receptors on the tongue to function properly.
When saliva production is disrupted, it can be a sign of different issues. One of the most common issues indicated by a decrease in saliva production is dehydration. When the body is dehydrated, it conserves water by reducing saliva production, leading to a dry mouth. This condition can also affect speech, swallowing, and increase the risk of dental problems.
Certain systemic diseases can also affect saliva production. For instance, Sjogren's syndrome is an autoimmune disorder that targets the glands producing saliva and tears, leading to dry mouth and dry eyes. Similarly, diabetes can cause dry mouth due to elevated blood sugar levels affecting the salivary glands. Saliva can also indicate the presence of infections. Elevated levels of certain proteins and enzymes in saliva can signal infections like viral hepatitis, cytomegalovirus, and others. Additionally, saliva can be used to detect the presence of oral candidiasis, a fungal infection more common in the individuals with weakened immune systems.
Another more recent interesting aspect of saliva is the use of it for diagnostic purposes. Saliva testing has emerged as a non-invasive, easy, and efficient method to diagnose and monitor various medical conditions. The science behind it is both fascinating and very promising for future healthcare.
Saliva tests are commonly used to measure hormone levels, such as cortisol, testosterone, and estrogen. These tests help in diagnosing hormonal imbalances and conditions like adrenal fatigue, menopause, and thyroid disorders. Since hormones in saliva reflect the free, biologically active hormone levels, these tests provide accurate and timely information.
Saliva is frequently used in drug testing for substances like alcohol, cannabinoids, and opiates. The saliva drug tests are less invasive than blood tests and can be administered easily without the need for specialized training. They provide quick results and are useful in various settings, including workspaces, roadside checks, and rehabilitation centers.
Advancements in genetic research have enabled saliva-based genetic testing. By analyzing DNA from saliva, companies can provide insights into ancestry, genetic predispositions for certain diseases, and even personalized diet and fitness plans. These tests have made genetic information much more accessible to the general public, empowering individuals to make informed decisions about their health.
Saliva tests are also being developed to diagnose diseases such as cancer, HIV, and COVID-19. For instance, researchers are working on saliva tests that can detect biomarkers associated with oral cancers. Saliva testing for COVID-19 has been a game changer during the pandemic, offering a less invasive and more comfortable alternative than nasal swabs.
It's also interesting to examine the salivation in other animals compared to human salivation. Similar to humans, most mammals have parotid, submandibular, and sublingual glands, though their size and output can vary widely. Animal saliva also contains enzymes, electrolytes, and other components. Some animals have specialized saliva, such as the venomous saliva of certain snakes or the anticoagulant-rich saliva of leeches.
Salivation is a crucial physiological process in both animals and humans, but there are differences in production, causes, and uses. In terms of the production of saliva, humans have three pairs of major salivary glands: the parotid, submandibular, and sublingual, along with numerous minor salivary glands.
Dr. Weaver, of all the factors determining the makeup of the saliva,
That's an
what
interesting
are the
thing.
most important differences between Homo sapiens
Recall when we
and
were
other
preparing
mammals?
this, Dr. Deneen and Dr. Lewis, that I said, should we include something about this? And of course, Dr. Lewis, you said, yeah, absolutely. How can you do it without it? And so there are some differences in the composition of saliva. Human saliva contains enzymes like amylase, electrolytes, mucus, antimicrobial agents, and growth factors. The composition can change based on factors like hydration, diet, and health. Similar to humans, most mammals have parotoid, submandibular, and sublingual glands, though their size and output also can vary. Animal saliva also contains enzymes, electrolytes, and other components. Some animals have specialized sativa, as we've already noted, such as venomous snakes and other creatures like mosquitoes and some other goodies that we're going to talk about in just a second.
There are many different reasons why saliva is stimulating. I know among humans it is a reflex action triggered by the sight, smell, taste, or thought of food. It also starts the digestion process by breaking down starches with amylase. Saliva helps to keep the mouth moist, as we said before, protect teeth from decay, and facilitate speech. Animals can also salivate in response to food stimuli. In some animals, saliva has additional roles. For example, some predatory animals produce excess saliva as part of their hunting and feeding process. Certain species of bats use saliva for its anticoagulant properties when feeding on blood. In many animals, saliva similarly aids in the initial breakdown of food. Some animals use saliva in predation, venomous bites, or as a defense mechanism. Certain species use saliva in scent marking for communication or territorial purposes. Human saliva is adapted for our complex speech mechanisms and an omnivorous diet. Adaptations can be highly specialized based on dietary needs, predatory behavior, and ecological niches. These differences highlight the diverse evolutionary paths and adaptations that salivation has taken in humans and in animals.
Yes, most animals produce saliva as it plays a crucial role in digestion and oral health. However, there are some exceptions, particularly among simpler organisms and specific invertebrates. Here are a few examples. Some insects do not produce saliva in the way mammals do. However, they may secrete digestive enzymes directly into their food to begin the digestion process externally before ingestions. Sponges do not have salivary glands or saliva. They filter feed by drawing water through their porous bodies and trapping particles, which are then ingested by specialized cells. Jellyfish, corals, sea anemones, they lack complex digestive systems and salivary glands. They capture prey using tentacles and nematocysts, which are stinging cells, and digest food in a central gastrovascular cavity. Certain marine invertebrates, like starfish and sea urchins, do not have salivary glands. They often have unique feeding mechanisms, such as extruding their stomachs to digest food externally. I don't know, that just strikes me as kind of humorous. While most fish produce some form of mucus or enzyme secretions in their mouths, the production of saliva, similar to that of terrestrial animals, is less common. For instance, certain species of fish may have minimal or no specialized salivary glands. Now, some animals, like some insects and starfish, begin digestion outside their bodies by secreting enzymes directly into their food. Sponges and some marine invertebrates filter microscopic food particles from the water, bypassing the need for saliva in breaking down food. Cnidarians use stinging cells to immobilize prey and then ingest it whole, with digestion occurring in a central cavity.
These adaptations often reflect their ecological niches and specific dietary requirements. Yes, the saliva of different animals can have varying effects, ranging from harmless to beneficial or even harmful. Some believe that pet saliva, such as that of dogs or cats, has minor antibacterial properties, though this has not been scientifically proven to be significantly beneficial to human wounds. The saliva of common pets, like dogs and cats, does not harm humans, though it may contain bacteria that could potentially cause minor infections if they come into contact with open wounds.
Pet saliva can carry bacteria from animals like cats and dogs, which can cause infections if introduced into human wounds.
The saliva of some wild animals can carry harmful bacteria or parasites. For example, raccoons can carry Leptospira bacteria, which can be transmitted through bites or contact with saliva. Some people are allergic to the proteins found in the saliva of cats and dogs, which can cause allergic reactions ranging from mild to severe. The saliva of venomous snakes contains toxins that can cause serious injury or even death. Venomous snakes inject their saliva, their venom, through their fangs, which can affect the nervous system, blood clotting, and other tissues.
Species like the Gila monster and the Komodo dragon have toxic saliva that can cause harm to humans.
Saliva from bats can transmit rabies, a potentially fatal viral disease if not treated promptly after exposure. Some rodents' saliva can carry hantavirus, which can be transmitted to humans and causes severe respiratory illness.
Mosquito saliva contains anticoagulants and proteins that can cause allergic reactions and transmit diseases like malaria, dengue fever, and Zika virus. Tick saliva contains compounds that can suppress the host's immune response and transmit severe diseases such as Lyme disease, Rocky Mountain spotted fever, and other tick-borne illnesses.
Leeches have long been used in medicine. Leech saliva contains anticoagulants that prevent blood from clotting, which can be beneficial in medical settings but could also lead to prolonged bleeding if not managed properly.
Now, while we're talking insects, flea saliva can cause allergic reactions in some individuals and transmit diseases like the plague and typhus. Now, my cat had an allergy to some of the a certain type of flea, and the infection was very severe, and had to be treated properly. Thank goodness the vet recognized what was going on. The effects of animal saliva on humans can vary widely depending on the species and the context of exposure. While some animals' saliva may be beneficial or neutral in their effect, others can transmit diseases such as and causing allergic reactions or even be toxic. It's essential to be aware of these potential risks, especially when dealing with wild animals or in regions where certain animal-borne diseases are prevalent. Okay, another thing that I experienced firsthand in the psych labs. Certain monkeys and apes, they're known to spit at other people. Though this behavior varies among species and contexts, here are some kind of examples. Capuchin monkeys have been observed spitting in various contexts, such as to express displeasure or as a form of communication. Some other monkey species may spit as a defensive behavior or to show aggression, especially in captivity or under stress. Chimpanzees are known to spit as well as throw feces, but they're known to spit often as a form of communication or to show displeasure. In captivity, they might spit at humans they find annoying or threatening. You know, spitting can also be used in play or as a way to get attention. Complex little critters. Other great apes like orangutans and gorillas are less commonly observed spitting, but it can occur, particularly in captivity, where they might pick up such behaviors from their interactions with humans or out of frustration. While not all monkeys and apes are known to spit, some species, especially capuchin monkeys and chimpanzees, do exhibit the behavior, as I've already said.
We could go on, but I think as we have, as some people would say, a spit shine on this topic. I hope you've enjoyed this and learned a bit. Please give us a like or a comment. Subscribe if you haven't already. This is our 99th podcast, friends, and I cannot believe how much has happened so rapidly. I thank you all, you, Dr. Weaver, and you, Dr. Lewis, for participating today, and our listeners. It's been a wonderful adventure and many more to come.
And I want to remind our audience that History Twists is there. We are just about ready to go public with it. We already have a number of podcasts done, actually, and there's some real interesting things that'll be happening there. And boy, it'll be a twist on our normal podcasts and a twist on history. And hey, we're getting Twister. Uh, um, and as we have the two series going with this one, the inventions series and the secretions series. So stay tuned for that. As Dr. Deneen said, please join us again. Give us a like and subscribe. Bye for now.
Wrong, folks.